Here are your solutions to the example problems. This is for section 5-6, which is about using the Pythagorean theorem. You all understand what the Pythagorean theorem states, which is basically a squared plus b squared equals c squared. Here we have the equation right here. So we're going to use that in order to solve a real-life problem. For example, here we have problem number 1 asks us to write an equation that can be used to find the length of the ladder and then solve round to the nearest tenth. Remember, we're always going to round to the nearest tenth for these Pythagorean theorem problems. So we have two legs here. We have 8 3/4 feet, or 8 75/100 feet, and we have 18 feet. So the ladder reaches 18 feet into the air, and it's 8.75 feet from the wall at its base. So we have a squared plus b squared equals c squared. Well, that would be 8.75 squared plus 18 squared is going to equal c squared. So we're going to calculate both of these numbers here, and we have the math done right here, and we end up with a total of 400.5625. Oops, 5625. And we need to take the square root of that, and remember, this is a plus or minus situation here because we started out with a variable squared, but in this case it doesn't make any sense to have a negative distance, and if we take the square root of that, it's going to be approximately 20. So our ladder is a 20-foot ladder. Another way to take a look at this problem is you literally could take your calculator and just press the square root of this 8.75 squared plus 18 squared all in one set of keystrokes in your calculator, and you will get the answer of 20. I'd like you to start trying to do that and understanding what you did there, because basically, remember, we're just going to take the square root of c squared when we're done, and therefore that means we're going to take the square root of this, so you don't really even have to figure these numbers out and then add them up and then take the square root. You can put it into the calculator as the square root of 8.75 squared plus 18 squared. I would suggest putting this in parentheses in your calculator and practice it a couple of times and make sure you can get that 20 out of there, and you can use that from now on. It'll save a lot of steps. All right, let's take a look at problem number 2. It asks to write an equation that can be used to find the height of the plane, then solve round to the nearest tenth. So we have a distance from the ground up to the plane as a hypotenuse here, right here, of 12 miles, and we have a distance that the plane laterally along the ground is 10 miles away. So we have an a squared plus b squared equals c squared problem. But the key is to make sure you put the right numbers in the right position. We can put the 10 miles either for a or b, it doesn't really matter. So we have a squared plus 10 squared has to equal 12 squared. So we have a squared plus 100 equals 144. That means if we subtract 100 from both sides, we will have a squared equals 44. We need to take the square root of that, and a equals the square root of 44. What you can see over here is about 6.6. Another thing you can do here is to think about the fact that what did we end up doing? In the end, what we really ended up doing is we took the square root of 144, in other words, our largest number, 12 squared, minus 100, which was this number, so minus 10 squared. So in other words, we took the square root of the hypotenuse minus one of the legs. And of course, they're both squared. So again, you could put this into your calculator all in one set of keystrokes. It's just the square root of 12 squared minus 10 squared. Take the square root of that and you will get this 6.6. Another good way to save some time here, as long as you understand what you're putting in the calculator, to work for you every time. The two variations are whether in this case you're looking for a leg. So what it comes down to is recognizing whether you're looking for a leg like you are in this case. We're looking for a leg, therefore it's a subtraction problem. If you're looking for the hypotenuse, then it is an addition problem, where you take the square root of the two legs. Please press pause and do letter A. Problem number 3 is about looking at the Pythagorean theorem in 3 dimensions. So let's take a look at what that means. A 12-foot flagpole is placed in the center of a square area. So we know that this is square here. So we have the same side length here. To stabilize the pole, a wire will stretch from the top of the pole to each corner of the square. The flagpole is 7 feet from each corner of the square. So this distance here is 7 feet. So I'm going to draw it over here in 2 dimensions. So we have 7 feet here. Okay, what is the length of each wire round to the nearest tenth? Well, we have 7 feet, and then we have a right angle right here because it's a vertical pole, and that pole is 12 feet long. So we should see right away that we're looking for a hypotenuse. So we're going to use this equation. We're going to take the square root of 7 squared plus 12 squared, which is exactly what we're doing here. Taking the square root of 7 squared plus 12 squared, and down here is where we're taking the square root of it, and we have 13.9. So we need about 13.9 feet of cable for each of these cables to stabilize the pole. Please press pause and do letter B. Again, it would be a good idea to draw this over here larger so that you can see exactly what you have here. We have 50 feet for a leg, and we have 61 feet for a hypotenuse, so we're looking for one of the legs. And right here is our right angle.